Hello, this is Mrs. Ringrose, and I'm here to teach you everything I know about polygons. So before I write down a formal definition, just know that some polygon examples might be our lovely square that we know and love, maybe a triangle, maybe something that looks something like a star. Hopefully that's what I can draw. But things that are not polygons is going to be your trusty circle, and then maybe something that looks like that, or even a semicircle. So maybe just based on those things, you're coming up with an idea about what a good definition for a polygon might be. And that's what we're going to talk about today. So a polygon is a shape on a plane that is closed. That's why that U looking thing is not a polygon. Also, the sides are line segments. Okay, and that's why our circle is not considered a polygon, because the circle has curves to it. Hopefully that makes sense. All right, the side of the polygon is, again, our line segments. All right, so that's pretty easy. Sorry, I'm not talking right now. I'm trying to make sure I'm spelling all these words right. You know how I am. So the sides are the line segment that makes and closes. See, as soon as I start talking, I screw it up. So line segment that makes and closes the shape. And we'll get into naming in a little bit. And the vertex, just like in an angle, the vertex is basically the corner. All right, so technically the technical definition is the point that the line segments share, or the sides share. And then we have something that's like so incredibly exciting, and we're going to spend a lot of time on this, so the sooner you know it, the better. Something called a diagonal. Diagonal is best shown when we've drawn. So I'm going to start us off with this trusty trapezoid. And a diagonal is a line segment. It's not just something. It's a line segment that connects corners that are not consecutive. So consecutive means you go in order. So this and then two, those would be consecutive corners. And if I tried to connect them, it would just be the side. So we also have a word that describes a line segment that connects angles that's not a side. All right, so connects. It's a line segment that connects opposite vertices. Okay, and again, we're going to talk about more on diagonals in a little bit. All right, so again, we have convex and concave, something that might be more helpful done by examples first. Convex polygon is going to be something that looks like a trapezoid, something that looks like a square, something that looks like a rectangle, something that looks like a triangle. A concave polygon is going to be something that looks more like this. All right, so the formal definition, I think, talks about something about how in convex polygons, all the diagonals live inside. So if I were to draw all my diagonals on these quadrilaterals, or I could, if I felt like I could draw a pentagon, and if I drew all the diagonals, actually, let's do that. Draw a little house. Meep, meep, meep. That's my favorite pentagon. And I draw all the diagonals. I get a star because there's 5 shapes. I'm sorry, 5 sides. But all the diagonals live inside. When I try to draw the diagonals on a concave polygon, they don't all live inside. This one right here ended up being outside of my polygon. So diagonals go outside. And it doesn't have to be all of them, it can just be one. Then we have angles, which is not going to be a huge focus right now, but when we get to triangles, we're going to absolutely revisit this vocabulary. So let's talk about interior and exterior angles. We know that interior means inside. So again, if I had the trapezoid, an interior angle would be, we're talking about the angle that's inside, so maybe angle 1, angle 2, angle 3, or angle 4. And then, if we're talking about exterior angle, for this one especially, I'm just going to draw a triangle. An exterior angle, you kind of have to draw out the side a little bit. You can turn it into a ray if you like. And then the exterior angle is the angle that is outside. So it is supplementary to that interior angle. And that's the relationship. Exterior angle it makes a linear pair, if you like that word better. Supplementary to the interior angle. And if you remember the word supplementary on that, then it just helps you, especially when you don't have that ray drawn, it helps you to not think that it's this entire, rest of the thing that makes a circle, because that would be wrong. Ever see the Croods where Ugg would just throw his hand up and say, they died. So that's kind of what I want to do here. Don't do that because it's wrong. All right, it has to be something that's supplementary to that interior angle. All right, so I hope that kind of gets you started on a good path with polygons, some of the basic vocabulary with that. There's these other words too real quick that we could talk about. Equilateral, equiangular, and a regular polygon. Or you can just stop me now if you've had enough and you can look those up. Equilateral, so equi on both of these, as you're probably guessing, means equal. Right? So the angular one basically means that all the angles are equal. Lateral comes from a word somehow that means side. And so equilateral means equal sides. So all the sides are equal. And you know about probably an equilateral triangle already. All angles equal. So an equilateral triangle is also going to be equiangular, and we'll get into that some more later. But that's not the case for every single kind of polygon. That only works for a... All right, and then we have regular polygons. And that just means, because as I was saying, not all polygons are going to be, just because they're equilateral doesn't mean they're necessarily equiangular. Sometimes you have to prove that. But a regular polygon is both equilateral and equiangular. And a good example of this, if you're trying to wrap your head around what these words mean and how could something not be equiangular and equilateral, just think about a rectangle, right? So in a rectangle, all of my angles are right angles, but all the sides are not necessarily the same, because these could both be 20 for a length and these could be 7 for a width, but yet a square, is regular because all the sides are the same. So these tick marks are going to mean. And all my angles are right angles. You also have something called a rhombus, which means that all the sides are the same, but the angles are not the same because you've got these two obtuse angles that should be equal in a rhombus, and then you have these two acute angles that are opposite. And so that is an example of something that is equilateral but not equiangular. All right, so I hope this vocabulary demonstration helped, and we'll be ready to do some fun stuff with polygons at our next class meeting. Thank you.